Today we're going to be looking at a few examples for applying our trig derivative rules. This first example, we'll start with a fairly simple example. Y is equal to secant x minus cotangent x. So here I just have the difference of two trig functions, and we're just going to directly apply those trig derivative rules. If I want to find the derivative of this function, the first part is secant x, and the derivative of secant x is secant x tangent x minus the derivative of cotangent x, which is negative cosecant squared x. And really the only thing we can do to simplify this is change that minus a negative to a plus. And so our answer is secant x tangent x plus cosecant squared x. In our next example, f of x is equal to sine x minus e to the x cosine x. Now in this example, I've got a difference of two trig functions, but my second term here, the cosine x is being multiplied by e to the x. And so for this term here, I'm going to need to use the product rule. So our derivative, f prime of x, would be equal to the derivative of sine x, which is cosine x, minus, and then with e to the x times cosine x, we're going to do a product rule. E to the x is my f, cosine x is the g, and the product rule is f prime g plus g prime f. So f prime, the derivative of e to the x, is just e to the x, times g, which is cosine x, plus g prime, which is negative sine x, times f, which is e to the x. And not much we can do to simplify this except to distribute this negative sign. So f prime of x is equal to cosine x minus e to the x cosine x. And then if I multiply the minus sign times, this is right here is plus a negative, so that negative times the negative will make that plus e to the x times sine x. And that's your derivative. One last example. Y is equal to 1 minus tangent x over 1 plus tangent x. So in this example, we've got the trig function tangent involved in a quotient. And so I need to be applying the quotient rule. The numerator, of course, is the f, and the denominator is our g. And the quotient rule is f prime g minus g prime f over g squared. So I'll start out with f prime, the derivative of my numerator. The derivative of 1 is just 0, and the derivative of negative tangent x would be negative secant squared x. So that's my f prime. I'm going to multiply times g, which is 1 plus tangent x, minus g prime. So the derivative of my denominator, the derivative of 1 is 0, and the derivative of tangent x is secant squared x. G prime times f, 1 minus tangent x. So just to double check, we did f prime times g minus g prime times f. And of course, this is all over g squared. All right, now on this one, I think we can do some simplifying. So let's multiply out our numerator. If I distribute that negative secant squared, then I get negative secant squared x minus secant squared x times tangent x. And then this minus here in the middle, I'm going to change that to plus and just put the negative with the secant squared and distribute it. So negative secant squared times 1 is negative secant squared x, and then we get plus secant squared x tangent x. And this is all over 1 plus tangent x squared. And it looks like in the numerator I've got a negative secant squared times tangent and a positive secant squared times tangent, so those can cancel out. And I'm left with 2 negative secant squared x, so negative 2 secant squared x over 1 plus tangent x squared. And that would be our final answer.